Thank you. Good afternoon, ladies and gentlemen, and thank you for the kind introduction. My name is Ravn Nielsen, and as told, Center Manager of the FCH Test Center, part of DTU Energy Conversion. Let me see how this works. The outline of my talk will be a brief introduction to what is the FCH Test Center and what is the department of the technical university that we are part of. I will tell you about the testing that we offer for companies and organizations. You will hear about the testing and standardization of test methods that we are involved in. And I will show you, tell you about demonstration projects that we take part of. And finally give you our contact details. So, the FCH Test Center, in this forum you will guess that it's fuel cell and hydrogen technologies. We are part of Technical University of Denmark and the department called DTU Energy Conversion. This department deals with technologies for energy conversion and storage, sustainable technologies, and has now 250 employees. We are mainly situated at the Risø campus, the former Risø National Laboratory, fairly close to Copenhagen. And more than 100 employees are dealing with fuel cells and electrolysis and batteries as well. We have been doing research and development and testing of fuel cells since 1987. And the commercial testing for companies have been organized through the FCH Test Center since 4 years ago. The department as such focuses very much on collaboration with industry, and the technologies we are looking at should be solutions, it should be scalable, it should be industrial relevant processes. And we span all the way from fundamental research and investigations and all the way for component manufacturing. We deal with solid oxide fuel cells, we deal with electrolysis, big effort within solid oxide electrolysis cells, but also a bit with alkaline electrolysis and PEM electrolysis. We deal with high temperature PEM fuel cells and has a group looking into hydrogen storage technologies. We deal with batteries and many more energy technologies. Please come to our booth afterwards if you want to hear more about the general activities. We develop materials and components. We develop manufacturing processes that can be scaled, that can be sufficiently cheap to, when the technology is ready, it can be scaled up in production. We do a lot of activities in advanced testing, developing own test methods, characterization of the components and technologies that we deal with. And we also have some activities within modeling. Here at the fair, me and my colleagues represent a dedicated effort within the department of commercial testing, assisting industry and organization in getting fast to the market by supporting with testing, training of engineers, training of technicians, as well as general consultancy. We offer advanced testing and demonstration of components and systems, and all based on research, and we can rely on research and experts within all these fields whenever there is a need for this. And we have our own standardized test procedures, and we deal with development of standardized test methods as well. So now to what kind of tests and testing that we offer you. We will be the right testing solution for your company whenever you need testing of fuel cells, of electrolysis, and batteries. We measure and test single cells and stacks and other components used within these technologies. Our very best competences are within electrochemical performance testing and materials characterization, which I will tell you a bit more about now. Coming up. Whenever we do performance testing of fuel cells or electrolysis cells, we will start out with electrochemical performance testing. We will do IV curves, we will do electrochemical impedance spectroscopy, and we will usually start out what we call a fingerprint. That is a very detailed analysis of your component, of your fuel cell, and that will tell you about the various losses, the resistance of various parts of the cell. So revealing how does this look like. We do this fingerprint by testing at a number of various temperatures, and we combine a number of gases on one electrode and the other electrode. And by all these combination and the experience we have already by testing and analyzing these systems, we can deduct where is the loss and where can the cell be improved. We also do the impedance testing on a stack level on SOFC, SOEC. So we can reveal the performance of the individual parts, and when we make this fingerprint in the beginning of a test and at the end of a longer test, it will also show you about the degradation that takes place, which part of the cell degrade, how much. The really top competences of our research groups is the interaction between electrochemical performance testing and microstructure analysis. These two disciplines really go very well together, and we have developed a number of advanced dedicated characterization methods, techniques for these purposes. So also the microscopy can tell you about the degradation and can usually confirm what we have seen from the electrochemical analysis. So is the degradation that will take place, is that due to impurities that are gathered at the grain boundaries? Are there grain growth taking place? Will the conductivity has changed due to less less interaction and interconnection of particles? Or does there take delamination place so the integrity of the cell disappears after testing? All this we can find out by microstructure analysis and comparing a cell that has not been tested to a cell after maybe a long-term or tough testing. And one method I want to really point out to you is how nickel particles can be detected if they are interconnected, or what we call percolated. So do they contribute to the electric conductivity of an electrode, or are they separate, isolated particles? We have this specific test method that running on low voltage scanning electron microscopy. We can have the nickel particles that are interconnected. They light up really bright and clear. And the nickel particles that are isolated will be gray and not bright at all. And thereby very easy to do image analysis and seeing has the microstructure changed before and after a test? How good is the microstructure? Should it be optimized? And yeah, what are the potential improvement here? We also have quite fine success in assisting companies doing corrosion testing of metallic interconnects. We can do it again under very relevant conditions. the right temperature, for example, 750 degrees, build up a small stack, put the metallic interconnects there, a number of repetitions so we get really good, reliable measurements. And then we measure how the resistance change in time, when it's corroded, when the oxide layer is formed. And we supplement this with microscopy afterwards and weight gain as shown here as the oxidation takes place. And another dedicated test method is testing of mechanical strength of ceramic components, which is the main component in the solid oxide cells. So we can, by this homemade equipment that we have a patent on now, measure at the high temperatures, at the relevant atmosphere, 4-point bending strength, at a number of samples in one heat up. For example, 16 samples. So in one run, we have a number of results, and in 2 runs, we have sufficient data to have reliable mechanical strength data that you can use for your stack design, for your troubleshooting, and you can optimize your processes, your heating process, your reduction process of cells and stacks. And very clear, when you have this number of measurements, you can say, okay, at what temperatures is this the strength? And if we change our process, how does that influence the strength? So this is a very unique setup. And the last method that I will tell you about, the newest at our laboratory, is the high pressure testing of solid oxide fuel cells and solid oxide electrolysis cells. Right now we are testing up to 20 bar, and we are ongoing with the construction and will end up with cell testing up to 100 bar and stack testing up to 50 bar. And as you can see, it's a pretty big pressure vessel that is carrying out this test. We take part in various European projects and efforts for standardization of test methods within these technologies. One that has been ongoing for 1.5 years soon is the stack test project dealing with PEM fuel cell stack test procedures for industry. And this project propose and validate industrial relevant test procedures for stacks. And we will end up with application-specific test programs, so that's relevant for specific industrial uses. And we focus on 3 aspects: the general technical performance, the endurance, so can this stack stand various conditions, long-term and tough testing, and environmental and safety testing. And I'm happy to tell that we are entering 1st of May another EU project dealing with, this time, solid oxide cells, both solid oxide fuel cells, solid oxide electrolysis cells, and also the reversible operation of SOFC and SOEC. We will, together with these other very competent test institutes in Europe, harmonize, develop, propose, validate test methods on cell level and stack level, or small stack level. And again, like in the PEM stack test project, we will tailor these tests for various applications, so it's relevant for various industry. Now to the demonstration projects. Many of you here will have heard about the Ennefield project, which is a large European project demonstrating micro-CHP units, combined heat and power units for residential purposes, Up to 1,000 units will be demonstrated in field trials throughout Europe. It's a 5-year project. There are 12 countries where the demonstrations will take place. There are 26 partners involved by this 8 manufacturers, sorry. And the technology involved is both PEM fuel cells, high temperature PEM, and solid oxide fuel cells. And from our side, DTU and FCH Test Center, we are dealing with the analysis of the data coming out, both technical data and less technical data by surveys for end users. And we will point out potentials of this new technology and also point out where there are barriers to overcome for this new technology to be rolled out in a mass market. For the last year, we have been doing a project together with the city of Copenhagen and a number of Danish partners, which analyzed how hydrogen can take place, can be a part of the energy system of Copenhagen. It has been an ambitious project in the beginning, like a feasibility study. How can we do this? What will the cost be? How should it be organized? Is there a business plan, a business case to follow here? And we have been planning a megawatt pilot plant. What will that cost? How long time will it take? What approvals do we need to get? And the idea is to take sustainable electricity, for example, from our wind power, produce hydrogen from electrolysis, store the hydrogen, use it for transport, use it for putting back in fuel cells to produce power back to the grid, and also introduction of hydrogen in the town gas, in the city gas of Copenhagen, and also see how the heat generated can be introduced to the district heating grid that is quite unique for Copenhagen area, Denmark and such. And we, by doing all these analysis and planning, we have been facing quite some challenges. So we have realized that even though the old town gas grid was based on hydrogen, it is no longer. And just by introducing like 2 or 4% of hydrogen, we will need a substantial amount of testing and approvals, which cannot, for a demonstration project, there's no reason to do this because it will be very expensive and take very long time. So this path we cannot follow. We also find by the economical calculations that the concept of balancing the grid by storage of hydrogen and feeding it back to fuel cells and back to the grid is not economically attractive on the short term, and not if it's not coupled to other purposes. And also because of these challenges, it has been not possible at the moment to find a commercial partner for operating this demonstration plant. So this still remains uncertain. We have a sea-based electrolysis project, H2 Ocean, where it's a design of an ocean platform for energy harvesting, and hydrogen will be the energy carrier. Our role is to be the electrolysis partner, and the idea is out on the ocean to remove the salt, desalination of seawater, use this for electrolysis, and then store and carry out the hydrogen. We are investigating how this salt, how the purity of the water influences electrolysis. And usually water quality is measured by the conductivity of the water. And we find that that's an okay measure, but it's more precise, and for this specific use, very important also to look at the exact ions present. So we deal now with the ion impact factor. So one ion is much more harmful if it is in great amounts than others. So the desalination process can be tailored so it comes exactly to the level that does not harm the electrolyzer. And I want to invite you to come to our booth. It's just a few meters down the hall here to discuss with Fredrik or Jonathan or myself what we do in the test center, what we can offer you from the department as such, or you can hear more about the projects we are involved in. Thank you for your attention.